Hi, and welcome to another Huygens screencast. Again, this is a little bit different than what I'm normally known for, but photography and panoramic photography is another passion of mine, so I'm doing a few screencasts on the topic. So this screencast is heavily inspired by a tutorial that I read on the Huygens website, a series of tutorials actually, that deal with stitching murals. So we're going to take a quick look at that. Here I have a few photographs that I took of a mural using my fisheye lens, and this mural is located in Mesa, California. And if we take a quick look at the larger version of the image, we can see that it's obstructed by this tree. And this is a very simple example of what you can do with Huygens and multiple photographs, but we're going to remove the tree. Initially, when I explain how this is done to people, they just sort of give me a blank stare and say, well, why don't you just use Photoshop? Well, Huygens maintains a level of accuracy in the photograph that I think Photoshop might struggle with. Or should I say the person using Photoshop to do this operation might struggle with. So I have a few photos here. I'm going to choose 49 and 50. I'm just looking at the last two digits of the files. And we're going to see what we can do with those. Let's just select these two images. There's not much EXIF data because my fisheye lens is uncoupled. It doesn't have any electronic contacts, so my camera doesn't even know when the lens is on it. So we can drag this in, and Huygens basically says, well, I don't know what kind of lens this is. And so I have to say, well, it's a 7.5mm lens. It's on a micro four thirds camera, so it has a 2x focal length multiplier. And it's a full frame fisheye lens. So once we've entered these parameters, it's enough for us to proceed. We can go to the Images tab, and we can see that the image number 349 is set as my anchor for both position and exposure, so that's okay. And the first thing we need to do is we need to explain to Huygens where the straight lines are, so that we can flatten this and do a mural stitch. Now I'm going to be linking the tutorials that inspired this video tutorial in the description and in the blog post accompanying it. So make sure to check those out because that's where most of this information came from. If we go to the Control Points tab and we select image 0 for both panes, we are basically set up to be able to assign horizontal and vertical lines, similar to another tutorial I did. So I like auto fine tune off and auto add and auto estimate on when I'm doing vertical or horizontal lines because it just makes things easier. So I'm just going to click and drag right to the edge of the beam and do the same thing down here, and it sort of zooms out and snaps once it thinks it has it. And you can always press the F key to fine tune the results a little bit more. So we see it's created control points in either image that correspond to a vertical line. So I'm just going to continue and add a few more points. So I'm going to add one that goes a little bit lower down. And I'm just clicking and dragging to add these points. And now I'm going to add a couple over here. And this technique works really well with all sorts of obstructions. And it's such a simple technique, but Huygens' workflow makes it pretty easy to work through this once you get past the learning curve. I'm not going to be apologetic for Huygens and say that it's an easy program to learn because it's not. It's very, very powerful, but it is not what I would call amazingly user-friendly. It's fairly user-friendly, but it does have its challenges. So I'm just doing the same technique here. I'm not spending too much time explaining how I'm doing this because I actually have other videos that talk just about adding horizontal and vertical lines to calibrate a fisheye image. But let's add one more point over here on the right before we take it over to the optimizer. So in Huygens, once you've added well, I tried to fine-tune the point and it told me no similar point was found. Usually when it does that, it messes up your alignment like it has here. So I'm just going to manually place point number 7 on the edge where I think it belongs and just leave it. I won't fine-tune that point. I press 0 to zoom back out. So now that we have all these images, we can actually go to the OpenGL preview, and what we see is not impressive. It's just an equirectangular projection of my fisheye image. Well, we haven't done any optimization yet, so this is normal. If we go to the projection tab and we change it to rectilinear, which is kind of what we're interested in, you see it sort of scales it and zooms it all the way out. We can just press fit to bring it back into the field of view, and this does look a little bit better. The image has sort of been straightened and it's not all curvy anymore, but our horizontal and vertical lines aren't really doing anything yet. If we wanted to see them, we can go to the preview pane and say show control points, and you can actually see what the control points we assigned are doing. I'll close the preview for now, and we can go to our optimizer now. Now, to start, I like to optimize positions, view, and barrel when doing a mosaic. So we select those and then we just say optimize now. Now, it's not going to optimize the other image, I don't think, because it doesn't have any control points. And so we can just run the optimizer. It has a maximum deviation of 0.394. I'm okay with that. And then we go back to the GL preview, and we can see that it has done a really good job of straightening the image out. So that's step one. That's really good progress. There's actually two images here, so I can turn off image number 1, and we can see just the image we just worked on. Now, we probably want to move and drag it so it's centered, but be careful. If you drag in normal mode, you mess up the calculations. You need to drag in mosaic mode. So we can drag it over in mosaic mode, so it's kind of centered. And then we can turn the other image back on. You can see it hasn't really been aligned properly yet. And we can just leave that as it is for now. Actually, let's go back in. What we can do is manually adjust the field of view so that we sort of trim out the parts of the image we don't care about very much. And we're just focusing on the part of the image we're working on. Now might be a good time to save the file, so I'm going to go ahead and do that. I'll just save it as the default file name. Okay, so now we can go to our control points tab again, and we can see that there are no control points connecting image 0 and image 1. Let's fix that. If we go to the images tab and select none or all of the images, we can just use Huygens default CP find to create some control points. You can hear the computer's CPU spring to life as it just does a lot of number crunching. And it analyzes the images using this command line utility. And once it has found control points, it lets us know. If we go to the control points tab again, looking at image 0 and 1, you can see all of the control points it added. Now I'll warn you, this might be enough control points, but it might not be. So let's just take a look at what happened. We can go to our optimizer tab, and we can run the optimizer again. This time it says we have 23, a maximum deviation of 23. So that's probably not going to look too good, but let's see what it gave us. Click the GL preview again. Things look kind of messed up. So this can happen when you don't optimize enough of the lens parameters. I've found that I get good results when I optimize pretty much everything: positions, translation, view, and barrel. So we optimize that now, and we only get 2.5 as a maximum error. So that's actually pretty good. Let's take a look at what the GL preview looks like. It looks a lot better. So we have image 0 and image 1, and you can see they're both almost perfectly aligned. One of the reasons they're not actually perfectly aligned is because of the control point distribution. If we look right here, we can see that there are spots on this image where we can see corresponding data in both photographs, but they're not linked by any control points. So the easiest way to fix this is to just add a few control points. So I'm going to click this palm tree, click the same tree over here, and we can fine-tune that result just to make sure it looks good. Alright, now when we're adding standard control points like I just did, it's a good idea to turn auto fine-tune on unless you have a really bad fit and Huygens is struggling to find a match. That enables you to click this black window, just sort of position it lightly, and see it tries to find one, but it turns out it was wrong, so we can actually move it over there and try the fine-tune. it fails again. But after we fine tune a few more times, I'm just pressing the F key, it figures out where it needs to be. So you can actually sort of automatically estimate, automatically fine tune the results. It depends on what your preference is, whether you want to leave it on or not. But in general, you just want to create some control points that are farther away. Make sure they get a good detail. Like here, I want the corner of this opening, not the center of it. And once I've positioned it, I can press F to fine tune it. And we can also look at like this palm tree up here. We can add a corresponding point on it. Run the fine tuning. See, sometimes it really just doesn't know what to do, but you can help it out by just manually moving the control points into place. And click the add button if it doesn't automatically add them. Once you've added a few more control points to the image, you can hit this button to run the optimizer again. You might get a better result, you might get a worse result. You just have to play around with it a little bit. So I just went back to my GL preview, and toggling between these two images, I think I'm happy with it for now. You can see, however, that the area I added the control points to is registered much better now. It almost doesn't shift at all when I switch between the two photos. So we went from having one photograph with a tree blocking it to two photographs with a tree blocking it. Not much of an improvement, but in these two photographs, because I took them from different angles and because of the parallax effect, the tree is actually not covering the same spot on either photograph, so it means we can just cut the tree out. Before I do that though, there is one important thing I wanted to mention. The tutorials that I'm going to link to mention this as well. If the automatic control point generation happens to place control points on things that are not on the surface of the wall, you're going to want to delete those control points. The reason is that will make your match very bad. It'll have a really, Hugin that is, will have a very difficult time aligning your images if all of the control points are not on the same plane. This is not the case if you're doing a traditional panorama, but if you're doing a mosaic stitch like we're doing here, multiple images sort of flattened and stitched together as if they were laying on the floor, it's really important that all of your control points are on a flat surface, a flat plane. So, okay. So, moving on, we can go to the mask tab. We have image 0 and image 1. Let's work on image 0 first. Now when you click add new mask, by default the mask is going to exclude what you draw it around. So I'm just going to draw a mask around this palm tree, and I'm going to sort of exclude the right half of the photograph starting from the palm tree. The reason I'm doing that is just because the right side of the photograph has less resolution because of the edge of the fisheye lens. So I don't mind throwing away the whole right half of the image. You could just mask out the tree by itself, but the resolution on the right half of image number 1 is a lot better than the resolution on the right half of image number 0 and vice versa. So we can just see here that when I added that mask, I just clicked to place a point and I double clicked to stop placing points. We can see here that we have an exclude region mask. So I'm going to do the same thing to image number 1, where I'm just going to draw around the palm tree. But on the other side of the image, and that's it. When we go back to our GL preview now, we're actually going to see the mural without the palm tree in front of it for the first time. Now, you might find areas that need better alignment. For instance, up here by the clouds, I can see that the two images meet and they sort of don't align perfectly. You can fix that simply by adding more control points or by deleting control points that have a bad match. What I mean by that is in the control points tab, if you look at the distance between the control points after optimizing, control points with a high distance value may actually make your alignment worse, but control points with a low value are good alignment. So if you wanted to make the top area by those clouds a little bit better, you would place a control point maybe on this cloud here that has that little swirl of detail, and then you would basically find that same cloud on this image with that swirl of detail, add a new control point. Then you can re-optimize, apply the changes, go back to your GL preview, and it's a little bit better. Again, it's not perfect, but it's better. Because we already moved the mosaic around and cropped it using the field of view adjustment sliders down here, we can move straight to the cropping stage. So we can go over here to the crop tab, and if we hover over each side of the image, we get the crop boundary. So we can actually just crop the image down by clicking and dragging from each side. And as you can see, the areas where we defined vertical and horizontal lines are really straight. And then we can just sort of crop it down there. I'm going to keep a little bit of the bushes in the image. Cool, so now we have this image, and we can close our preview. We can go to our Stitcher tab and say Calculate Optimal Size. That's going to make the canvas a little bit bigger than it was and sort of compensate for a few things like how many images there are, what our crop looks like, and all that. I want to save this as a TIFF. You can choose JPEG or PNG if you want. Ping apparently is how PNG is pronounced. And then once you've done that, you can just say Stitch. It'll ask you where you want to save the image. In this case, I want to save it next to the others, but I'll call it Stitch. And then I just hit Enter for save, and it opens up the batch processor. Once the batch processor is open, you can actually close Hugin. This runs as a separate program, and you can see here that it's running my panorama stitch. It's in progress, and it's basically opening up the images, applying the masks we defined, and then blending the images together after, of course, distorting the images using the optimization that we did to them. Once it's complete, you should see your stitched image right here. If we open up this image, we can see that despite our hasty application of this technique, it looks pretty good. We can't really see the seam where the two images blended. I know it's somewhere around here. And even up at the clouds where we were worried about, and we added some extra control points, it looks pretty good. So this is something I've been playing with a lot lately. Taking murals that have ugly infrastructure and obstructions in front of them and sort of trying to extract them out onto a canvas where you can sort of look at the piece of art all straightened and at the right angle. So I hope you guys enjoyed this sort of little tutorial, this little technique. Again, it's not new, it's not my idea. Hugin does this, and there's some tutorials out there that show you how to do it. I'm going to link to those. So I really hope you enjoyed it, and if you did enjoy it, let me know. I'd love to hear from you.